Alright guys, so these are my notes on using the Pythagorean theorem to solve some word problems. And usually word problems are a little bit tough, but these ones really aren't. We're going to do some real world problems dealing with the Pythagorean theorem. So now that we've done Pythagorean theorem for a couple days and done some squares for a couple days, let's use our skills to solve some word problems. There are a lot of problems in real life dealing with Pythagorean theorem because there's a lot of right angles or a lot of 90-degree angles in real life. When doing these problems, the hardest thing is figuring out which one is A, B, and C, and then after that, I'm sure you guys saw last time, it's really pretty easy. You just need to plug it in, like any other volume formula or area formula or something like that. Now, the big thing that we need to remember is that C is the hypotenuse, or the side that is across from the right angle. I also said C is usually the biggest side, but it's not always 100% obvious which one is biggest because one of them is going to be missing. And a big thing too is they don't give you a picture, just draw one yourself. I think this next one down here has this drawing one. After that, I think I give you a couple where it gives you the picture. All right, so let's do a couple examples. I really don't have that much for you today. I think there's only like 3. So this one says a 20-foot ladder is leaned against a wall. The base of the ladder is 8 feet from the wall. How high up will the ladder reach? So again, pretty easy. I stink at drawing, but I'm going to draw a wall. I'm going to draw a ladder. As you can see, my ladder's terrible. And it says a 20-foot ladder is leaned up against the wall. So that being said, that means that this right here, the green, is 20 feet. The base of the ladder is 8 feet from the wall. So that's 8. You guys see the triangle that it makes, hopefully. Obviously, right? Like, there's 20, there's 8, there's my right angle. And the big thing that we talked about doing yesterday, again, other than writing down the formula, is figuring out if they give you the hypotenuse or not. Do they give you the hypotenuse in this one, or do they give you C? Well, if you draw your arrow on the little box on the 90 degree, you can see that it does point at 20, and that's the thing that goes into my C. So yeah, they do give you the hypotenuse on this one. Looking at that 8, the way that I drew it, I would see that it's A. It doesn't really matter if you plug it into A or B though, so I'm going to plug in 8 into A, and then all we really need to do is solve this equation. We know how to solve equations. We've practiced it the last couple days. 8 squared is 64, plus B squared is, now I would usually pull out a calculator for a number this big, but 20 squared isn't that bad either. I think you know what it is. 100. Okay, so now I'm almost on my equation. Now it's sort of like a 2-step equation, except there's an exponent there. It's not like we did in the beginning of the year. How do I solve that? What do I have to go to first? The thing that's attached or not? Obviously not, so it's minus 64 on both sides. This is where I'm going to bust out my calculator and be lazy. 400 minus 64 is 336. And don't forget this line right here, Mr. Hood. Remember to solve for the variable, not the variable squared. Like I have B squared right now, it obviously just wants regular B. So how do I get rid of that square? Square root both sides. And I have no idea what the square root of 336 is, and it's not going to be a perfect square, I'm pretty sure. So let's take the square root. I get 18.33. So B, I'm just going to say 18.3. So that's how long that side is. 18.38 up against the wall. There it is. Pretty easy. Basically what we did yesterday. I think I have, 2 more examples to go over with you guys, or 1 to go over with you guys, and 1 for you to do. So let's take a look. On example 2, I'm talking about some baseball stuff going on here. A guy throwing from second base to home, I believe. Yep. So he's going to throw from second base to home. And as soon as I do that, hopefully you guys can see a triangle there. I definitely do. Right? We don't know how big this side is. The other sides are 90 feet. That's pretty obvious. You guys see where the right angle is? Down at first base. And if you use the arrow technique like I do to figure out if they're giving you the hypotenuse or not, you can definitely see that the hypotenuse is the thing that's missing this time. So when I plug into a squared plus b squared is c squared. I know the hypotenuse is missing. I know that this is going to be the thing that I don't know. So that being said, that a and b are going to be 90. So now let's figure out what that is using your calculators. 90 squared. Do you think you know what it is even without the calculator? 9 times 9 is 81, so this should be 8100, right? 8100. Look at it. 8100 plus another 8100 is c squared. When I combine those two, because again, I'm just solving an equation, I'm doing some simplifying. 8 and 8 is 16, 1 and 1 is 2, so this is going to be 16200 is c squared. And here's where I definitely need a calculator for. No idea what that is. 16200 square rooted. I get 127.3. Now let's just make sure that they're asking for that distance. This is, for example, if he's standing right on second base, how far does he have to throw the ball to reach home plate? Yeah, 127.3. Be careful about what they're asking. I'm going to give you a tip right now. On the next quiz or test I give you, I think it's going to be really, really close to this problem, and I'm going to ask how much less is it to throw from second to home versus going from second to first and then to home. So you'd obviously have to do a little extra thing after that. Alright guys, so I have two for you to try now. I remember one being a little bit tougher than it looks, so just be careful when you're doing that one. So pause the video, try 1 and 2 for me, and unpause it to check yourself. Hopefully there's enough time for you to be able to pause your screen there. Let's take a look at number 1. Obviously it's Pythagorean theorem. I see a triangle, so I'm going to put a squared, b squared, and c squared. This one gives you a lot of the dimensions already. I'm going to find my hypotenuse by using the square trick, and I see that's the thing that I don't know. So that means that the other two values are going to be going into A and B. Obviously 34 is smaller, so I'm going to put that one into A, 41 into B. I have no idea what those are off the top of my head, so I'm going to do 34 squared in my calculator to get 1156. And 41 squared on my calculator is 1681. And that's all equal to c squared. How do I simplify those? Obviously there's a plus sign in between them, so let's add them together. Plus 1156. 2837 is c squared. Square root both sides, and I end up getting some random value of 53.3, let's call it. So C is 53.3. Now, when I asked you guys to pause the video, I said this one might be a little bit more challenging than it looks, and I'm assuming a lot of you stopped there, but you guys know what was more challenging about this? Well, if you even just read the last line of the question, the only thing I can really see, it says how many meters will be saved if it were possible to walk through the pond. So if this is 53.3, I don't want to walk through the pond, obviously, because I don't want to get all wet, unless I got some of them fancy muck boots. Don't I usually have to walk like that and like that? So how many meters am I actually walking if I'm going to do the way that I'm supposed to do? I'll obviously got to add up 41 and 34 to figure out that you're walking 75 meters. So how much am I saving if I go through the pond? Well, obviously that's just going to be 75 minus 53.3. So let's do it. And I end up getting 21.7. So again, I said on a quiz or a test, you guys are going to get a question like that. I think it's even the one dealing with the baseball one. So let's see this last one. I think this one is a little bit easier. Basically, just like the first question that we did together, it says firefighters have a 17-foot extension ladder in order to reach up 15 feet up the building. How far away should it be placed? So let's draw a building. Maybe put someone out of the window because there's fire all over the place. That's my fire. Maybe I'll color it red. and we're trying to save that person. We need to put a ladder up there, and the ladder that these firefighters have is 17 feet long. So let's color that one 17 feet. We need to reach 15 feet up the building. We need to figure out how far away we should put it. Well, I see my triangle in green. I see my right angle right there. And if I draw it to make the hypotenuse, okay, so now let's plug in. I end up getting 17 is my hypotenuse. 15 is one of my sides. The way that I drew it, it looks like 15 is the bigger of the two sides. So I'm going to put 15 in for B and then try to solve for A. So I know it's going to say A squared is 225. Yes, I have that one memorized. I don't have 17 squared memorized though. 289. What do I have to do here now? 5 on both sides. To get A squared is 289 minus 225. 64. And last step is square root both sides. To get A is 8. So that missing side is 8. It should be 8 feet from the burning building. Alright, so I have some final thoughts, and then we're done. There are a bunch of real-world Pythagorean theorem problems because there's a lot of right angles, or a lot of 90-degree angles in real life, all the time with the building. Pythagorean theorem is A squared plus B squared is C squared, where A is the blank side, small side, and C is the big side. To undo squaring, you take the square root. When solving Pythagorean theorem problems, you're solving a or an equation. So use the rules for solving an equation, like you need to get rid of the thing that you're not attached to first. Most real life problems will not be perfect squares. All right, guys, that's it. Thank you so much for watching.